Welcome to the Glide Automation Mission Planning Software demonstration. This software is web-based. You can find it on our website once you have an access key. It will work with all browsers, but we suggest Google Chrome. Let's get started. We will begin by going through the software's interface and controls. The map interface uses normal controls. Click and hold to pan the map. Scroll the mouse to zoom. The Settings button opens a window which holds settings about your machine, as well as the mission to be planned. We have satellite, 3D terrain, and regular view controls in the top left. You can search for an address at the bottom left, use the file controls at the bottom, and the drawing tools on the right-hand side. This first demonstration will use GPS recorded coordinates to plot the boundary and obstacles. We can access that file using the Open button. This boundary and obstacles were recorded using the Auto Slasher. As you can see, the boundary and obstacle alignment on this site closely matches the satellite imagery. This is not always the case. If absolute precision is not required, you can simply draw the boundary and obstacles using the pencil tool on the top right of the interface. Note that satellite imagery is not always reliable and should be checked before being relied upon to plan an autonomous mission. Because we have verified the alignment of satellite imagery using the recorded data, we can easily use the satellite imagery to confirm positions and place the start and stop locations for the mission. These points do not need to be within the boundary. Press the flag icon to create these points. Follow the prompts and click the map to select the desired positions. Performing concentric laps of the boundary is recommended before doing any parallel passes. We can program the laps here with the circular pattern button. Note that the amount of concentric passes created is defined in the settings window. Now, let's add some parallel passes. Click the Add Snaplines button and draw the desired direction of lines onto the map using 2 clicks of the mouse. Once the snaplines are created, we can group them into one continuous string of passes using the Generate Path button. Once the tool is selected, use the Line tool to highlight the desired lines to include in the group. Press the Tick button to accept the selection. We can create multiple path groups by repeating these steps. Once all desired areas of the mission are covered with groups, we need to use the Join Groups function to interconnect these into one continuous path. Click the Join Groups button and follow the prompts. A purple line will appear, showing the connection path. Click the mouse to add nodes to this line, routing the connection path as required. Press Enter to accept the path and continue this until all groups are connected. We have now successfully planned our mission. We can simulate our mission to see some calculated information. Note that these values are calculated estimates, and real-world times may vary depending on many factors. Use the speed slider to adjust the animation speed. The selected speed is displayed in meters per second and is not a realistic representation of actual machine movement speed. We can use the play button to visually simulate the mission, demonstrating the order in which groups will be performed. This final step is crucial to ensure the planned route matches expectations, and the machine will not traverse any unplanned areas. Once you're satisfied with the planned route, use the Save button at the bottom of the screen to save your mission. Rename this file to something suitable and transfer it to your machine using a USB. You're now one step closer to unlocking the power of automated land management. Thanks for watching.